Hi children, I am going to introduce matrices from the chapter Algebra. Okay. So, we all should know that what do you mean by matrix. See, in front of you we have been a calendar. Why the calendar has been on the screen? So, you should see the numbers on the screen, that is on the calendar, from 1 to 30. The numbers are arranged. They are arranged in a row and a column. So, you all know that in a week 7 days are there. We will have 7 numbers on the horizontal row, and we will have 4 weeks or 5 weeks, that is 4 weeks only, that is in the column wise. So, in the calendar we are introducing the rows and the columns. Now, I am going to tell you how the matrices are used in our day to day life also. Now, I am going to tell you the matrix, how the matrix will be. It is mainly based on rows and columns. So, matrix is a singular word and matrices is a plural. Okay. So, now for example, if I consider any matrix, we all have a name, like that the matrices also will have a name of it. So, name can be introduced by the capital letters alphabet. A is equal to. Now, I told you the rows and the columns are nothing but the matrix. So, what are the rows? How the rows will be, how the columns will be. Now, if you have any element on that, A11, A12, A13, A21 and A22, A23, A31 and A32, the last one is A33. Okay. This is a matrix. Now, we have 3 rows. We have 3 rows. That means the horizontal thing is known as a row. So, this is R1, R2 and R3. Row 1, row 2 and row 3. How many columns are there? The vertical thing is known as a column. Now, this is C1 and C2 and C3. Now, we have 3 rows and 3 columns are there. So, this is considered to be a matrix, and it should be, all the elements should be embraced by a bracket. It can be a square bracket or a curved bracket, whatever it may be. This is the name of the matrix. So, this matrix always should be specified with the name of it. So, A is equal to. So, what are the inside things? These are all called elements of the matrix. These are all called elements of the matrix. How many elements are there totally? We have 9 elements are there. Now, we are going to see the different types of matrices and the order of the matrices and so on. Now, generally we are saying that what is a matrix? A matrix is a rectangular array of elements. The horizontal arrangements are called rows and vertical arrangements are called columns. As I told you, the horizontal arrangements. So, horizontal arrangements are called rows and the vertical arrangements are called columns. Now, the example also they have given it 8, 4, minus 1. So, 8, 4, minus 1, that is the first row, and 1 by 2, 5, 4, that is the second row, and 9, 0, 1, that is the third row. So, we have 3 columns, 8, 1 by 2, 9, and then 4, 5, 0 and minus 1, 4, 1. So, like that 3 columns we have. So, this is the definition of a matrix. Usually, the matrix is a rectangular array of elements. The horizontal arrangements are called rows and the vertical arrangements are called columns. Now, what is the order of the matrix? So, we have a name, we know that. And what is the order of a matrix? General form of a matrix A with m rows and n columns, that is order m cross n, can be written in the form of. So, how many rows are there? We have m rows are there. See that A11, A12, etc., A21, and the last row is AM1, AM2, AMJ, etc., AMN. What it is that? The first number M1 is there. The first number M refers to the row and the 1 refers to the column. So, M1, that is the last row, mth row and the first column. Like that, mth row, second column, and mth row, third column. So usually we will have like that. That is, usually the order of a matrix can be defined in a way m cross n or m by n. So usually the number of rows should come first and the number of columns should come next. So when giving the order of a matrix, you should always mention the number of rows first, followed by the number of columns. Now we are going to see the types of matrices. So many types of matrices are there: row matrix, column matrix, square matrix, diagonal matrix, scalar matrix, identity or unit matrix, zero matrix or null matrix, transpose of a matrix, that is very important, triangular matrix, equal matrices, the negative of a matrix. So we are going to see one by one. First one is a row matrix. What do you mean by a row matrix? In the name itself, it is clearly said it is a row matrix. So row matrix means that it has only one row and any number of columns. So row matrix means you have only one row, but the columns may be different. So a matrix is said to be row matrix if it has only one row and any number of columns. A row matrix is also called as a row vector. For example, A is equal to 8, 9, 4, 3 is a row matrix of order 1 by 4. So what is the order? Order is the first number refers to the rows and the second number refers to the column. So first row 8, 9, 4, 3. As I told you, what is the first row? It is a horizontal line, is nothing but the row. So horizontally we have only one line, so the row is 1. And the columns 8, 9, 4, 3. All the 4 numbers are there. So we have 4 columns. So in general, A is equal to A11, A12, A13, etc. A1n is a row matrix of order 1 by n. So it is clearly said that row matrix means the row should be numbered, the number of rows should be 1 and the column should be any number. Now the next thing is column matrix. So as I told you before, the column matrix topic itself, it is clearly understood the column should be 1. A matrix is said to be a column matrix if it has only one column and any number of rows. So the number of columns should be 1 and the row should be any number. So it is called a column vector. For example, B and C are column matrices of order 2 by 1 and 4 by 1. See why I said 2 into 1 and 4 into 1. It is not the 2 into 1. It is 2 cross 1 or 2 by 1 or 4 cross 1 or 4 by 1. We can call it as like that. So B and C are column matrices of order 2 by 1 and 4 by 1. So for example, C is equal to 8 minus 3, 23, 17. So we have 4 horizontal lines and we have only one column. So it is clearly understood that it is a column matrix because the number of columns is 1. So in general, A is equal to A11, A21, A31, etc. is a column matrix of order m cross 1. So why it is m is the number of rows and 1 is the number of column. Next is square matrix. So what do you mean by square matrix? You know, all of you, square means what? All the sides are equal. So all the 4 sides are equal. That means it should be a square. So the same way, a matrix in which the number of rows is equal to number of columns, then only it forms a square, no? So number of rows, it should, suppose the number of rows is 2 and the number of columns is 2, then we will form a square matrix. So that means the number of rows and the columns both must be same, then it is known as a square matrix. A matrix in which number of rows is equal to number of columns is called a square matrix. So A is equal to Aij, that is order is m cross n, m by n. What is Aij? Aij is nothing but the elements which are present in the matrix, those are called Aij. So I can take any value and j can take any value. So will be a square matrix. Aij m by n, the order is m by n, will be a square matrix if m is equal to n. What is that m is equal to n? That is number of rows and the number of columns both must be same. Then it is a square matrix. Is a square matrix of order m. Suppose the number of rows and the number of columns both are equal, we can say it is a square matrix of order m. Next comes diagonal matrix. So what do you mean by diagonal? As I told you again, the diagonal. So, diagonal, it is something connected with the diagonal. What is a square matrix? If you have a square matrix, all of whose elements except those in the leading diagonal or 0 is called a diagonal matrix. So, what is the diagonally? We will use the word diagonally, no. So, the diagonal, in the diagonal we will have the numbers. So, other numbers, other elements are zeros, then it is known as a diagonal matrix, where it should be like this. In a square matrix, all of whose elements except those in the leading diagonal or 0 is called a diagonal matrix. So, for example, they have given it. It is 8 0 0. See that all the elements are zeros and except the leading diagonals. So, a square matrix A is equal to Aij is said to be a diagonal matrix if Aij is equal to 0, if I is not equal to 0. What do you mean by that? I is not equal to j means what? Row number and the column number, if they are not same, then the value is 0. See that? It is a diagonally. Diagonally means what? It is a A11 and A22 and A33. What do you mean by that? A11 means 1 is a row and 1 is a column. 2 is a row and 2 is a column, and 3 is a row, 3 is a column. If it is in that case, the numbers will come, otherwise it is all fully zeros. Now, for example, one more example also they have given it. It is a diagonally we will have 2 numbers and one more number can be as 0, but not all times. Next is a scalar matrix. So, what do you mean by scalar? A diagonal matrix in which the leading diagonal elements are equal is called a scalar matrix. So, diagonal matrix means it should be the leading diagonal should be a number, other things and all 0. The same way, the diagonal matrix in which leading diagonal elements are same, it is equal, all are equal, is called a scalar matrix. For example, 4 0 0 4. So, 4 and 4 are diagonals. So, same number k 0 0 0 k 0 0 0 k. So, all are k's, diagonally we have all k's, and 5 0 0 0 5 0 0 0 5. So, all 5's only. So, this is called a scalar matrix. That means diagonal, the leading diagonal elements are equal, then the diagonal matrix is nothing but a scalar matrix. So, in general it is said to be a scalar if Aij is equal to 0 when I is not equal to j. That means the row number and the column numbers are not same, then the value is 0. Number of rows and the number of columns both are same, then the value is k, where k is a constant. Next is identity or unit matrix. So, identity or unit matrix. This is a square matrix in which elements in the leading diagonal are all 1 and rest are all 0 is called the identity matrix or unit matrix. So, square matrix in which all the leading diagonals are all 1. We have seen that leading diagonal elements are different, we have only the numbers, and all the diagonal elements are same. Now, we are seeing that leading diagonals are all ones, then it is known as identity or unit matrix. So, a square matrix in which elements in the leading diagonal are all 1 and rest are all 0 is called a identity matrix or unit matrix. So, thus the square matrix A is equal to Aij is an identity matrix. So, the same condition they have given here also. A unit matrix of order n is written as IN. N means what? It is of order. So, I2 means it is 2 by 2 matrix. I3, it is a unit matrix with the order 3 by 3 or identity matrix of order 2 and 3 respectively. Now, the next is 0 matrix. So, what do you mean by 0 matrix or null matrix? The word 0 itself, the word 0 is there everywhere. Null matrix, the word null itself, you know that a matrix is said to be a 0 matrix or a null matrix if all its elements are 0. As I told you already, the elements which are inside the matrices are all 0, then it is known as a 0 matrix, or all 0 matrices of order 1 by 1, 2 by 2, 3 by 3. It is a number of rows and the number of columns must be same, and 0 0 0 0 0 is a 0 matrix of order 2 by 3. It is not necessary that the columns and the rows must be same, it can be varied also. So, number of rows can be 2 and the number of columns can be 3, but inside that all the elements are 0, then it is known as 0 matrix or null matrix. Now, this is very important, this transpose of a matrix. So, based on this, we have in the first exercises so many sums are there. What do you mean by transpose of a matrix? So, the matrix which is obtained by interchanging the elements in rows and columns of the given matrix A is called transpose of A, and it is denoted by A transpose. So, what do you mean by that? Suppose for example, 1, 5, 8, 9, 4, 3. 1, 5 is the first row, 8, 9 is the second row, 4, 3 is the third row. So, third row, and how many columns are there? 2 columns are there. So, we have the order of the matrix B is 3 by 2, and for this how will you write the transpose of it? So, we have 1, 5 as a row. Now, you change that 1, 5 row as a column. So, you write that 1 as it is, 5 should be below that as a column. So, 1, 5 and 8, 9, 8, 9 is the second row. So, 8, 9 it is horizontal, it is a second row, but you have to write it as a column. So, 8 under that you can write it, below that you can write it as 9. Then third one is 4, 3. 4, 3 also third row can become a third column. So, 1, 8, 4, 5, 9, 3. Note that A transpose, whole transpose is equal to A. What do you mean by that? When you are finding the transpose of any matrix, that is the first step. Again you are finding the transpose of already what you have transposed, no, that matrix, then it comes the same matrix what we have in the question. So, that is only if you find out the transpose of any matrix one time and the second time, then you will get the same matrix which what is given in the question only. That is why we have given that A transpose, the whole transpose is equal to A. If order of A is m by n, then order of A transpose is n by m. So, that is rows have become columns and the columns have become rows. Triangular matrix. So, triangular matrix, what it is triangular matrix? So, square matrix in which all the entries above the leading diagonal are 0 is called a lower triangular matrix. So, square matrix, this is also a square matrix. What do you mean by square matrix? The number of rows and the number of columns are same, that is a square matrix. So, in which all the entries we can have it as all the elements, and in the above the leading diagonal, you have the leading diagonal, you know the diagonally what are the elements are there. Above the leading diagonal are zeros, above the diagonal it is 0, then it is known as lower triangular matrix. In other way we have to take, if all the entries below the leading diagonals are 0, then it is called a upper triangular matrix. So, for example, they have given it the matrix A is equal to 1, 7, minus 3, 0, 2, 4, 0, 0, 7. There you can find the leading diagonal is there 1 to 7, below that all the elements are 0, all the entries are 0. So, it is known as a upper triangular matrix. And the second one is 8, 0, 0, 4, 5, 0, minus 11, 3, 1. We have the diagonal as 8, 5, 1, but above the leading diagonal we have zeros. So, that is known as a lower triangular matrix. Now, equal matrices. What do you mean by equal? See, here only the equal matrices. We are comparing two matrices, that is how they are equal. Two matrices A and B are said to be equal if and only if they have the same order. What do you mean by order? That is number of rows and columns again, and each element of matrix A is equal to the corresponding element of matrix B. So, first condition is it should be of same order. It should be of same order, number of rows and the number of columns in both the matrices must be same. And the second condition is A is equal to the corresponding element of matrix B, that is each element of matrix A, that is every element. If it is A11, there it is A11. So, that is known as a corresponding elements. Otherwise, A21, there you have to find out A21. So, the every element of the matrix A is equal to the corresponding element of matrix B. that is Aij is equal to Bij. What do you mean by Aij? The elements which is in the matrix A is known as Aij. The elements which is present in the matrix B is known as Bij for all ij. That means for all ij means what? I can take any value and j can take any value, but the equal matrices means both must be same. For example, A is equal to 5, 1, 0, 3. It is a square matrix of order 2 by 2. B is equal to 5, 1, 0, 3. The same. The elements are also same and the order is also same. Then A and B have same order. So, A and B are equal matrices. Negative of a matrix. So, negative of a matrix, here again it is a singular, it is a matrix. So, negative of a matrix means what? The negative of a matrix A m by n. M by n means what? It is a order m by n. It is denoted by minus A m by n is the matrix formed by replacing each element in the matrix A m by n. The order of A is of order m by n with its additive inverse. What do you mean by additive inverse? If you have the positive values, then the additive inverse of it is the negative value. If you have the negative value as an element, then the positive is the additive inverse of it. So, the negative of a matrix A is of order m by n, A denoted by minus A is of order m by n is a matrix which is formed by replacing each element by the additive inverse. So, that is every element of minus A is a negative of the corresponding element of A. As I told you, you have the elements in A. What are the elements you have in A? It is 2, minus 4, 9, 5, minus 3 and minus 1. So, we have 2 rows and 3 columns. The order is 2 by 3. But you want to find out the negative of a matrix. So, A is there. You want to find out the negative of it. What do? 2 can be replaced by minus 2 and minus 4 can be replaced by 4, 9 can be replaced by minus 9, 5 can be replaced by minus 5 and minus 3 will be positive plus 3 and minus 1 will be plus 1, that is again a positive. So, negative of a matrix is just you are finding the additive inverse of what they have given. Let us have the simple problems. Now, progress check. We have find the element in the second row and the third column of a matrix. They have given 1, minus 2, 3, 2, 1, 5. First of all, we should know what is the order of that matrix. A is equal to 1, minus 2, 3, 2, 1, 5. This is the matrix. How many rows are there? We have 2 rows. How many columns are there? We have 3 columns. So, horizontally we have 2 rows and vertically we have 3 columns. So, the order is 2 by 3. Now, find the element in the second row and the third column of the matrix. So, which is the second row? 2, 1, 5. This is the second row. And which is the third column? This is the third column. 3, 5. This is the third column. This is the second row. And this is the third column. So, second row and the third column is meeting at the point, that is the 5. Okay. So, second row and the third column, this is the number 5 which is there in the second row and third column. So, instead of writing that second row and the third column, how can we write? So, we will have to write it, the element A, second row, that is 2, column is 3. So, 2, 3. So, A 2, 3 is nothing but 5. We can write in this way also. The element A 2, 3 is equal to 5 or the element in second row and third column is equal to 5. This is very easy to find it out. It can be in a multiple choice question also. What is the element which is there in the particular row and the particular column? We will pass on to the next question. Find the order of the matrix. In the same progress check, find the order of the matrix. This matrix is given sin theta, cos theta, tan theta. Now, the order of the matrix they are asking. First of all, we will write what is that matrix. A is equal to sin theta, cos theta and tan theta. Now, how many rows are there here? See, whenever they are asking the order, we must see that how many rows and how many columns. That is the first thing. So, now one row horizontally we will have one row, second row and third row. So, the number of rows, how much? 3. And we should see number of column, number of columns. See that how many columns? Only one column is here, no other column. So, we will have to write number of columns is 1. Now, they are asking order of the matrix. Therefore, order of the matrix A is equal to, how we said, that is number of rows should be there and cross number of columns, that is 3 cross 1, or we can say 3 by 1. 3 by 1 is the order of the given matrix sin theta, cos theta and tan theta. Now, so far we have seen what is a matrix and what is the order of the matrix and how can you find out the order of the matrix. Before that, what is a row and what is a column. And the next one is we can locate the element, where the element is, that is in which row and in which column, that also we have seen. After that, we have seen the different types of matrices, we have seen that. So, different types of matrices: row matrix, column matrix, scalar matrix and diagonal matrix, identity matrix and so many, triangular matrix and equal matrices and negative of a matrix. So many matrices we have seen that. I suppose all of you have understood very clearly these type of matrices. Then we are coming to the end of the session. Now, after this we will meet you in the next session. I suppose everyone has understood properly, and please practice yourself using what I have taught you. Thank you.